Good evening. My name is Grace Hayek, and on behalf of the Glencoe Public Library, I welcome you to our program tonight on eclipses with Dr. Shane Larson. As you will know very well by the end of this program, we have two eclipses coming up in our near future, an annular or ring of fire one this Saturday, October 14th, and a total eclipse on April 8th. Now I'll introduce our presenter. Dr. Shane Larson is a research professor of physics at Northwestern University, where he's the associate director of CIERA, that's CIERA, which is an acronym for the Center for Interdisciplinary Exploration and Research in Astrophysics. He works in the field of gravitational wave astrophysics, specializing in studies of compact stars, binaries, and the galaxy. He works in gravitational wave astronomy with both the ground-based LIGO project and the future space-based observatory called LISA. He is an award-winning teacher and a fellow of the American Physical Society. He contributes regularly to a public science blog at rightscience.wordpress.com and posts on what many of us still call Twitter with the handle @ScienceJedi. This is not Shane's first GPL rodeo. He's been doing programs for us for, I think, 7 or 8 years now. And he is officially this library's favorite astronomer. Tonight, though, is the first time that he's been back in person since before COVID. And Shane, it is great to have you back in the building. And I will let you take it from here.
Okay. Well, thanks everyone for being here, and thanks to Grace and her staff for inviting me. We've been doing these on Zoom for many years now. Even after COVID, I think, as most of you know, it's kind of been hard for us to all get used to being in rooms together. But it's always a great pleasure to be in front of real live people again. But we do have folks on Zoom. So as we go through this, if you have questions, please do ask them. I'll answer questions as we go along, because if you're confused, almost certainly the person next to you is confused, and one of you has to be brave and ask the question. Okay, so that goes as well for our friends on Zoom. If you do have a question, Natalie's monitoring, and if you speak up or raise your hand so that she knows, she can make me pause. Okay, we'll certainly take times to answer questions at the end as well. I do have eclipse glasses, which I'll hand out in the middle of this all. There's a stack here of extras, so I will leave them with Grace. So all of you who are on Zoom, if you come into the library, return your overdue books, then she'll give you a pair of eclipse glasses, right? Okay. So we are going to talk about eclipses. Stand in the shadow of the moon is literally what we're going to do during the eclipse. There are other kinds of eclipses that aren't in the shadow of the moon, and we can talk about those if you want to. But specifically today, we're talking about eclipses where the moon is the object doing the job. So I'll do my best to explain it to you. I'll give you some details very specific to Chicago. Okay, so or the Chicagoland area. So that means times and how long it'll happen and that sort of thing. But if you do travel anywhere in the United States, you will be able to see both of these eclipses. Okay, there is only a very narrow range of places you can go where you can see the fancy bit of it, the ring of fire or the total eclipse. But anywhere in the United States you can travel, you'll see what we'll see here in Chicago, or a variant of what we see. Okay, so you can carry this information with you. You can call your aunt and uncle, your kids who are living far away, and tell them everything I tell you, and they can go use it in their backyard too. Okay, now Saturday is the annular eclipse that's coming up. We picked our date well, and so it's going to happen very rapidly, and then you'll have until April to ponder the total. But if you have questions, then my email address is right here. Don't forget the period. The period's important. And if you send me an email, I will do my best to point you at a resource, send you to a book, an online article, something to help you figure out the answer to your question. I can certainly answer questions if I know the answer, and I will. Okay. My blog is here, and I've written about, in particular, the last total eclipse at my blog. So if you go there, you can kind of read about what the last one was like to give you a sense. I also wrote about the last annular eclipse at my blog as well. So that was in 2012. I saw that one too. So, okay. And of course, you can certainly follow me on social media. So this is an artist rendition of the eclipse, what an eclipse might look like in space. It is fanciful in the sense that it shows more color than your eye will actually see during this event. I'll show you a picture that I think is accurate to what your eye will see. But nonetheless, it kind of does show the kind of key features of what we expect. The sun, the bright surface of the sun will be completely blotted out enough that you can see this event with your naked eye during the moment of the eclipse. And at the very last moment, this is a very famous configuration that we'll talk about as we go. Okay? Okay, so I am at Sierra. We do lots of these public lectures. We have lots of events that we do. So if you're interested in more sciencey, nerdy astronomy stuff, you can certainly visit us at our website and see all the different things that we do around Chicago. And then, you know, I'll be back at Glencoe eventually, one way or the other. So, okay. Okay, so this really is a story about the sun, and it all begins with the sun. I think in ways that we don't often think about, the sun is really the reason everything goes on here on Earth. It drives all the energy of everything that happens on Earth, beginning with the plants. The sun falls on the plants, the cows eat the plants, we eat the cows, and our energy comes from the sun through that pathway, right? All of the weather is driven by the sun. The land is heated, it evaporates the water, that drives the air currents, the winds move across the country and carry the clouds, and they drop the water back to the earth, okay? The seasons are all about the sun. We are intimately tied to the sun, and that's something that we as humans have really understood. Even if we don't understand it the way I might teach it to you in a physics or astronomy class, humans have really understood that point for the entire time that we've been on the planet. And so you can only imagine what it must have been like for the first person hanging out, standing somewhere, and the sun gets blotted out of the sky, right? It would have freaked you out. But we have the advantage of living in the future. We kind of understand the motions of the planets and the clockwork of what goes on in the sky well enough that we can predict that these events happen. And so that's the story we're going to tell you tonight. What we as modern humans know is going on and how we predict and how we describe what's happening so that you can say, man, I really want to see this in person. I'm driving to San Antonio, and you get there at the right time. Okay? Okay. So it begins with the fact that because the sun is shedding light in every direction out into the universe, bright light, just as bright as you see when you go stand outside. If you go stand outside in the sun, you cast a shadow. And it doesn't matter where you are. If you're standing here in Glencoe, you cast a shadow. If you go to Evanston, you cast a shadow. If you go to Chicago, you cast a shadow, because the sun's shining everywhere that you and I have access to. And that's true in the entire space around the sun. So if the sun's way over there on that side of the screen, it's shedding its light this direction through space. You and I are standing right here in Chicago, I guess it's probably up there, casting shadows because the sun's shining on us. But the entire Earth itself is casting a shadow just like you and I do on the ground. It's just there's nothing in space for that shadow to fall on, so that you and I can see the Earth's shadow. The moon is orbiting the Earth. And the moon is also casting a shadow behind it. And we never see that shadow because there's nothing in space for that shadow to fall on. But every now and then, because we're moving around the sun and the moon's moving around us, everything lines up just perfect. So the shadow falls on us. Okay, so I liken this. How many of you like drive around O'Hare often? Right? You can't not drive around O'Hare in Chicago, right? Every now and then, you know, when I'm driving around O'Hare, a shadow of a plane flies over me. And it's not very often, but it happens because just at the right time, in the right place, I'm in the right place, and a jet passes between me and the sun. And that shadow falls on me. I'm like, whoa, what was that? Oh, it's, you know, United Flight 2142. Okay. Well, this is the same thing. Every now and then, when the Earth is in the right place, the moon will pass in front of the sun, and that shadow will fall on the Earth. And so we will have an opportunity to stand in the shadow of the moon. Okay? So if you're in the shadow of the moon, that's called a total solar eclipse. Okay? So the sun's over there doing its business, sending its light out into the universe. The shadow of the Earth is stretching behind the Earth. It goes all the way out into space. The shadow of the moon, wherever it is in its orbit, stretches out behind the moon, all the way out into space. And if it just so happens that the sun and the moon are lined up in the right way, the shadow will fall on the Earth. It doesn't stay put, it moves because the moon is constantly moving in its orbit. Everything moves in its orbit constantly. And so as the moon moves, the shadow moves. Just like when you walk down the street, your shadow follows you, right? There's a whole Peter Pan story we could make about the moon and the shadow, right? I'm totally sure of that. Okay, so that's the deal. So this is the astronomy textbook description of what's happening. We're standing on Earth, and if you're standing in the right place, the shadow of the moon will fall on you. Okay? Now, whoops, did it not advance? There are different kinds of eclipses, and we just told you there are going to be two different kinds. There's one called an annular eclipse, and then there's one called a total eclipse. Okay, so the case where you get a total eclipse is you're looking at the moon. The moon passes between you and the sun. So in reality, you're really looking at the sun. You can't see the moon because the sun's so much brighter. Like I'm staring at that projector right now and I can't see any of you. Okay, but if the moon passes between you and the sun, if you're big enough, it will completely block out the sun. So right now, I'm standing in front of this screen. And if you're over there watching, I'm not close enough to completely block out the screen. But if I stand up here, I'm big enough compared to the sun that I can completely eclipse the screen. Okay, so what we see depends on how far from us on Earth the moon actually is. And in a total solar eclipse, the moon is big enough to completely block the sun. And so what you see is a big black circle in the sky. Okay, you will see some stuff around the sun that's called the corona. I'll show you a real picture of that very soon. That's the atmosphere of the sun. You all maybe have seen pictures of solar flares and all of that stuff that happens on the sun. This is all that stuff that the sun's constantly throwing out into space. Okay, and it surrounds the sun in this area called the corona. Okay, the moon, though, isn't always this distance from the Earth. Sometimes its orbit's a little farther, and sometimes it's a little closer. And when I get closer to you, I look bigger. And when I get farther away from you, I look smaller. And the moon's the same way. When it's close to the Earth, it looks bigger, and it completely blocks the sun. But if it gets farther away, which it is sometimes, okay, then it looks smaller than the sun. And so the way we draw this here, you see these red lines. This is a line from you to the edge of the moon. That's the part, all the moon is the part that's casting the shadow. So this is really the line where the edge of the moon's shadow is. And you see it doesn't completely block the sun because the moon is smaller than it was up here. If I draw the same lines here, they completely block the sun. Okay, so that's the technical diagram. But what's happening is, here's the moon, it's close, it blocks the sun. Sometimes it's farther away, and it doesn't completely block the sun. So when it doesn't completely block the sun, I can see that edge of the sun, and I can see that edge of the sun. And so what you see is a ring of the sun is still there. And the problem is that when it's like this, you can't tell the sun's eclipsed. Because every little square meter on the sun is 1 billion times brighter than your eye can look at and be able to not squint and see anything. Every little bit of the sun that's exposed here is just as bright as the sun normally is. And so when the moon is in this phase, in these annular eclipses, if you're not paying attention, it just looks like a sunny day outside. Okay? But I'll show you pictures of what it looks like. It's actually not. Okay? So these are the two kinds of eclipses. This is this Saturday. This is in April. Okay? And in 2012, there was one of these. Did anyone see the one in 2012? Scott did, okay, many of you, okay. And this was in 2017. Did anyone see this one? Okay, okay. The awesome thing about the one in 2017 is it went through Illinois, okay, over Carbondale and kind of diagonally up towards, I guess it went kind of to the southern end of Indiana. So in April, it's going through Illinois again, over Carbondale, So Carbondale gets two of them. Okay, and this time it's going through Indiana. So it's coming up from the south this time. Okay, so Illinois is the X marks the spot for this particular pair of eclipses. We're kind of lucky. Okay, but I'm going to talk to you about both of these. Okay, questions about that before I start showing you pictures and all of that sort of stuff. Everyone good?
Why is it called annular?
Yeah. So that's a great question. So the question is, why is this called an annular eclipse? So this is fancy math language, right? So these kinds of nested circles are called annuluses. Okay, and so this is a term from mathematical physics. And let's see, what was the movie? I think it's there's some movie, The Mummy, maybe. So anyways, there's some fancy lock there. Oh no, it's Angels and Demons with Tom Hanks. So in Angels and Demons, they try and open the door and it won't open. They run off and he's like, no, it's an annular lock. And then he turns it and opens it up. It's because it's shaped like this. So, okay, sorry, movie trivia with science all in one. Okay, so anyways, that's a great question. Okay, it's technical language. We aren't always great about making better names when we tell you about these things.
I thought it was annual.
No, it's annular. It means it's an annulus, as we call it. Yeah.
Is it fair to say that in the winter, late fall, you're always going to get the annular, and in the spring and the summer, you're always going to get the total?
Yeah, that's a great question. So I think the answer is no. So you get so the reason is that the reason the moon is closer and farther at different times is because the orbit of the moon is not perfectly circular. Okay, but the moon's orbit and when it's close and when it's far is completely independent of the Earth's orbit, which is what defines the seasons. So there will be times when it does line up that way, but it's not generically true because the lunar calendar, as many of you may know, is different than the solar calendar that we normally use. Yeah. Okay, that's a good question. Other questions? Everyone good? Do you have a question, Caleb? What did I what? This?
The eye.
It's the eyeball. This is supposed to be your eyeball watching the moon go in front of the sun. So as astronomers, when we draw these pictures, right, we don't want to draw a whole person here because it would take up the whole screen. So I just draw your eyeball. Does it look like your eyeball? Okay, good. I did a good job then. I'm not a great artist. So, okay, other questions? Okay, we good? Okay, so let's talk about the annular eclipse, and then I'll tell you about the total eclipse. So the annular eclipse is this band here, okay? You see it goes diagonally across the United States. It comes ashore in Oregon. So I'm originally from Oregon. I went to high school in La Grande, which is up here in the corner. It will travel diagonally down through the United States and then go into the Gulf of Mexico down by Corpus Christi, okay? The last time the annular eclipse came across the United States, it kind of went on a track like this. I actually saw it here in Utah in Cedar City the last time it was here. So what this is a movie, I'll play it. So if you watch, this will be the time at the center of the eclipse, and then it'll tell you the speed that the moon's shadow, this black circle, is moving across the surface of the Earth. Okay, and then this is the maximum duration of annularity. This is basically when you're standing in a spot and the shadow passes over you, if you're right in the center, how long will the sun look like a ring of fire? Okay, and so I'll show you a movie of the total as well. The same kind of information will be plotted, but this will let you practice staring at it. Okay, so this is this weekend. It will come ashore about 9 a.m. Pacific time. Okay, all the Oregonians will be trying to get out of bed and drinking their coffee and watching it. But it's traveling at 3,000 miles an hour across the surface of the Earth. If you could see this, right, the annular eclipse doesn't completely blot out the sun, but if you could see it, if you could stand on a mountaintop, you would see it coming across the landscape at you at these kinds of speeds. And in Hawaii, when the eclipse passes over Hawaii, there are famous pictures from the top of Mauna Kea of them watching this thing come across the ocean at them. Okay, but the landscape of the Earth doesn't necessarily let that happen. But you can see very rapidly, so it'll all be over by 10 o'clock in the morning in the Pacific coast. Okay, and that's because it's traveling at some gazillion thousands of miles an hour. Okay, and they'll pass off into the ocean. It doesn't end here. So if you can, charter a shrimp trawler or something and want to go watch in the Gulf of Mexico, you certainly can. Okay, but this is the way to do it. Several of my students aren't here this week because they're traveling to the center line to see the annular eclipse. Okay, so what will it look like? Okay, so this is a map. Here's the path that I just showed you as the movie. So anywhere inside this path, you will see the ring of fire. Anywhere outside the path, you're only going to see the sun partially eclipsed. Okay, and you can see these little pictures. Okay, it's going to look like a cookie that Cookie Monster is taking a bite out of. Okay, but no matter where you are in North America, you will have the opportunity to see the sun with a little Cookie Monster bite taken out of it. And so we're here in Chicago. We're between the 40% and 50% line. And so if the rain's not blowing sideways in Chicago on Saturday, you will be able to see the sun with a Cookie Monster bite taken out of it. Okay, the closer you get to the path, the more of the sun you see chunked out. If you're in the path, you'll get the maximum amount. On the other side, it'll slowly get less and less again as you get farther away. Okay, so this is from a site called Great American Eclipse. I'll have links of slides of websites and stuff for you at the end. But if you want maps like this, information about any particular location, this is a great site you can go to get information. Okay, so what's going to happen? This is what a partial eclipse looks like. Okay, and even if you're on the center line, in the moments before the eclipse actually reaches the ring of fire, this is what it's going to look like. Not dissimilar from what we're going to see here in Chicago. That's because when I'm standing there waiting for the ring of fire to happen, I can watch the moon slowly move across the face of the sun, taking out bite after bite after bite. And the sun becomes more and more and more like a crescent, until finally the moon is completely in front of it and you get the ring of fire. Okay. Now, why do we call it the ring of fire? Well, it's a ring, okay? But we call it the ring of fire is because none of this can you look at with your naked eye, okay? It's too bright because every little bit of the sun that's exposed is as bright as the normal sun is. And you will hurt your eyes if you stare at it. So what do? This was taken with a special telescope. I have a telescope called a personal solar telescope, a PST. Okay, and it looks at the sun in the red light of hydrogen, and that's what you're looking at here, right there. But if you don't have this, what do? Well, that's why I brought you eclipse glasses. Okay, so eclipse glasses are they're made to easily be carryable around in your purse or your backpack. As Grace said, you should protect them. So I keep mine in an envelope, so that I'm not scratching the surfaces of the lens here. But the lenses are opaque. If you look through them, there is not a light in this room that will, nope, not even the projector light, that will get through them, okay? So when you look at the sun, it only looks through a fraction of the sun's light. So when the eclipse is happening, when you're going back and forth, I can't see right now. When you're going back and forth through this part, I can put on the glass. I could go out when the sun's full and put on these glasses, but during the eclipse, I can watch the slow cookie cutter bits come in and out as the moon goes across the sun. And then at the moment of the ring of fire, if I put these on, I will see this, not in this red light, but in more like that yellow light that I just showed you. And you will see the sun is a little ring in the sky. Okay. Now, if you lose your eclipse glasses before then, at the end of the talk, I'll give you some other ways to do this, okay? But let me go ahead and hand these around. There's not a billion people here, so if you have a couple of kids at home, please take a pair for each of them. The eclipse is not something that happens in just like 2 seconds, so everyone doesn't need their own pair. You can share. But, siblings don't like to share. So make sure you have them for all the siblings. Spouses can decide if they're going to share or not. Okay. Grace, you want to hand those out to folks? And I'll leave extras with Grace. You will find them around. Everyone's going to have them. The Adler will have them. Yerkes will have them. I'm sure everyone will be trying to get them out as we get closer. Okay. Okay. Questions about the Ring of Fire here, and I'll show you what it's going to look like here in Chicago. So
I was gonna say, that's only for the 90%.
yeah, so this is, you have to be in that central band that comes ashore in Oregon and leaves through Corpus Christi. Yeah. Okay.
If you're there, will it get dim?
Yeah, so that's a great question. So if you're just kind of leading your life, right? You're going and having pizza and then going shopping and going to the library and returning your book, you may not even notice because the sun's still pretty bright. And when we were at the last annular eclipse, the annularity happened kind of late in the afternoon. It was like at 3 p.m., 4 p.m. And so it kind of felt like we were getting close to sunset. It kind of got a little bit redder, you know, but then you're like, oh, it's just kind of getting towards sunset. Maybe there's fires in the air or something. But what I really noticed was it got cooler, right? Because we'd been standing out there in the sun for hours. And when the moon was in front of them, you could totally tell it was not as warm as it normally felt. But if you're not paying attention, you're just like, oh, it's colder today, right? But if you're paying attention, if you pay attention for the whole event, you absolutely will notice the world is different. Yeah. Okay, that's a good question. Grace.
What time on Saturday should we be?
So I will get to that. That's a great question, but give me 2 slides and I'll get there. I'll give you the times for Chicago. Okay, perfect. That's a great question. Obviously, the thing I should be telling you. Okay, other questions before I get to that? Everyone good?
No.
Yes, ma'am.
Why do we have to wear glasses? Why can't we just look at it? What happens?
Right.
What is the difference between the light?
Right.
This
That's a great
and
question.
a regular sun.
Right. So there's nothing different about this than the regular sun, right? You shouldn't go out right now and look at the sun with your eyes like that. We all do all the time. We're like, whoa, it's bright, right? But your body responds. It makes you squint because it knows the sun is putting too much energy on your eyes, right? So you know how like when you look at the bright light of the sun and then you look away, you see that red spot? That's because the chemicals in your eye are just surging, trying to respond to what it's seeing. And we know prolonged exposure in that way is damaging to your eyes. So you shouldn't do it. Yeah. This allows you to safely see the event and not have to worry about your eyes. You can focus. That's right. Yeah. There's a very famous story, right? In the olden days, they didn't know this, right? And in the olden days, in the days of Newton, they thought it was safe to look at the sun if you looked at the sun in a mirror. Okay, it is not. Okay, but Newton tells this famous story, or in one of his diaries, there's this story where he stared at the sun one day in a mirror for like 3 hours. And then what he wrote in his diary is, I sat in a dark room for 5 days and I could still see the image of the sun on my eye. Because it just so much energy on your eye, it just makes that, you know, that thing you see when you look at something too bright, right? Yeah. So it's dangerous to look at the sun unfiltered ever. Okay, these are a mechanism that allows you to do it safely. Okay, and if you do it in the presence of an astronomer, we'll do our best to protect you. Right? Okay. Okay, so wear your eclipse glasses. If you're going to look at the sun, just wear your eclipse glasses. Okay. Everyone good? Okay. Oh, you must use your eclipse glasses to look at the sun. Okay, and that's because the bright parts of the sun are exposed. Okay. Okay, so you will see lots of people taking pictures. Here in Chicago, if it wasn't blowing rain sideways, it's during the middle of the day. So there won't, maybe down near the skyscrapers, people might take cool pictures. I don't know. But especially this is from the last one when it's down, you can't quite see it, I guess, in here, but there's a nice landscape and you can see shadows of trees and stuff. So the photographers go nuts when these events happen. And if you pay attention, they'll flow through your social media streams, Sky and Telescope, all the astronomy sites will have like the best eclipse pictures from the recent eclipse. And they make great backdrops for your computer, cool things on your phone until the next awesome astronomical thing happens. Okay? Okay. So here's a great one. This is right. I love the photographers who do this. They show it at every stage. So this, if you watch through your eclipse glasses, at the start of the eclipse, it'll just look like a normal sun. You'll see a cookie bite taken, cookie bite. It's almost a crescent. This person chose, I'm going to have a cool ocean picture. I'm not going to stand on the center line. So they didn't get the ring of fire, but then the cookie slowly went away and it went back to normal sun by the end. Okay, so this is the whole sequence. This takes quite a few hours. Okay, so to Grace's question, what's going to happen in Chicago? At the maximum here in Chicago on Saturday, this is what you would see. So less than 50%, somewhere between 40 and 50% of the sun will be covered. The sun will be blocked out by the shadow of the moon. When you look, you will not be able to see the shadow at all. You'll just see this yellow part of the sun because your eclipse glasses will block out everything else except the light from this yellow crescent. Okay. So we're right here. Okay. So that's between the 40 and 50% line. Okay. And so it'll look somewhere between these two. So the partial eclipse, the first moment you look at the sun and there's a little tiny nibble taken out of it, will be at 10:37 a.m. Okay. Now, since we're expecting the rain to be blowing sideways that day, right? What you should do is starting around 10:30, you should every 15 minutes or go out and see if it's actually clear where you're standing. Because you know how it goes here, right? There's a thunderstorm in Glencoe, but it hasn't reached all the way to Edgewater, right? And it's finally cleared up over near O'Hare, but it's still storming near the lake. So just kind of starting around this time, check outside and see if you can see the sun at all. And if you can, take your chance and go look, because starting at this time, anytime you go look, some little bit of it is going to be chewed away. The maximum, I guess it's 54%, okay? That number can't be right.
45.
I think I have a typo. I think it's 45. I must have flipped them. Okay, it'll occur right before lunchtime. Okay, so right around noon, if you go out and it happens to clear where you're standing, it'll be about 45% of the sun looked out. Okay, and then the very last moment, the last little nibble of the sun, it'll be the normal sun again, 1:22. Okay, now those times are unique to wherever you are in the country. So if there are sites that you can go to and you just use, it's like a Google map, you click where you're going to be and it will give you this list of times. Okay, but these are the times for Chicago, so they're roughly right for anywhere here in the Chicagoland area. Okay, every phase of the eclipse, if you're going to look, you use your eclipse glasses. Okay, if there's anything you learn from this talk, it's use your eclipse glasses. There will be a quiz at the end. Okay. Okay, is everyone good? Questions? Everyone have a picture of this? Everyone's used their photographic memory and memorized these times? Okay, if you pay attention, they should be talking about this. You'll see it in the newspaper in the weather section. I'm sure Adler will post about it. We'll post about it at Sierra. So just there will be ways to get these times if you can't remember. And Grace will have them. So if you call Grace, what did Larson say? She'll tell you. So, okay. Questions about this before we go on to the April eclipse? Everyone good? Any questions from Zoom? All the Zoomers are good? Okay. They're all busy booking flights to go see it where it's not going to blow rain sideways, right? Okay, so April 2024. Now, fortunately for us, you all know that the weather is awesome in Chicago in April. Okay, so this will be your big chance to see the eclipse. No, sorry. Okay, it might be clear in April. Okay, so if you really want to see this eclipse, you just got to be cognizant of what the weather's going to be like. Okay, fortunately, it's traveling diagonally across the United States. I'll show you a map from the south to the north. And so as you get closer to the north, the weather's going to be more like spring weather always is for us. As you get closer to the south, then the likelihood of clearer skies improves. So you can think about this and plan your trip appropriately. Okay, this solar eclipse is the last solar eclipse that crosses the last total solar eclipse that crosses the United States until 2045. Okay, so in 2045, I'll be 27. No, I won't be. You'll be 27. Okay. Now, that doesn't mean there are total solar eclipses. There are total solar eclipses in the world every year. You just have to travel to them. Okay. In 2027, there's going to be a total solar eclipse that goes across Spain and Gibraltar and Luxor in Egypt. So if you really want to see an eclipse and you miss this one, you can travel to Gibraltar or Egypt. Okay, and then the year after, they will be somewhere else. They just are constantly all over the world. But if you want to travel in the United States, this is your last chance to see a total solar eclipse until 2045. Okay, so what's this all going to be about? So this total solar eclipse, as I said, is going to travel diagonally across the United States. It's actually going to come ashore in Mazatlan. So maybe that's the place to go watch the eclipse. It will come into Texas, and you will see it's going to travel over several major American cities. San Antonio is just inside the line. I'll be west of San Antonio on the center line. It's going to travel over Dallas. Okay. It's also traveling at thousands of miles an hour, just like the annular eclipse was. Okay. And it will just make its way up the center and the eastern seaboard of the United States. Question.
Okay, so it's traveling at this crazy speed.
Yep.
But if we drove with it, you wouldn't have to drive that fast to follow it, right?
Yeah, you could follow it, but it would eventually run away from you. Okay, so there are people who get in airplanes and try and fly under it, right, for as long as they can. But this is far faster than you can keep up with. But you could keep up with it for a little while. Okay, you can see the durations here. If you just stand still, it's going to take 3 or 4 minutes for the shadow to pass over you. So driving, in principle, you could make that last 5 minutes, 6 minutes, something. Okay, as long as there weren't other people doing the same thing as you and you have to watch where you're going and not watch the eclipse. Right. Okay. Make your teenager drive and you just lay in the back of the truck and stare at the eclipse. Right. Yeah. Okay. Okay. But it will go ashore over the northern part of the U.S., right along the American-Canadian border. I think Niagara Falls is in totality. So maybe that's going to be you can imagine what the photographic pictures are going to look like over Niagara. Okay. It'll travel over the eastern seaboard of Canada and then off into the ocean. Okay. Okay. So. Again, if you go to Great American Eclipse, you can get a nice map like this. You can kind of lay it out and figure out where there's a good city if you really want to be on the center line. Chicago, you'll see, is slightly outside of it. So you won't be able to see the sun totally blocked out. You're again going to see a partial eclipse, not that dissimilar to what we're going to see on Saturday if you just stay put here in Chicago. Okay. If you happen to be in Carbondale, you'll see a total solar eclipse. So I will tell you a story about Carbondale from the last eclipse. So I was in Wyoming for the last eclipse, so I wasn't here, but I had a friend who was in Carbondale. She was there with the Adler Planetarium, and they put everyone in Carbondale in the theater, or in the stadium. Okay, so that's where SIU was. And so there were clouds that day in Carbondale. Okay, so this was in August. And right at the moment the eclipse happened, the clouds were blocking the view for half of the stadium. And so half of the people saw the entire eclipse. But apparently about 30 seconds before it ended, the clouds kind of moved on and everyone got to see the whole eclipse. Okay, but I can just imagine the pandemonium. So anyways, so the weather is always the issue. And people who do this, they will often pick a spot. You know, I'm going to go to Cleveland. It's right on the center line. And they'll watch the weather reports and watch the news. And, you know, 7 hours before the eclipse starts, they're like, man, they're predicting clouds here in Cleveland. And they'll get in the car and they'll try and drive someplace where the weather's going to be better. So I had friends last time, the eclipse last time started in Oregon. It kind of went through diagonally this way and went off in South Carolina. So I had friends here in Kentucky who drove south to Tennessee and they got to see it because it was cloudy where they were in Kentucky. So people absolutely do that. Okay, so just be right. If you're totally hot to see the eclipse, you got to be flexible and nimble because Mother Nature doesn't cooperate as far as the weather's concerned. Okay,
So the one that we'll see here, it won't.
it will not be total.
It will not be dim.
Yeah.
But will this be dim? Will we notice it in Chicago?
If you're not paying attention, just like I told you about the last one, if you're not paying attention, you probably will not. I'll show you at the end. There will be ways you might notice because I'm going to tell you what to look for. And if you're just kind of walking down the street, you'd be like, whoa, eclipse is happening. And there are things you can see if you know what's going on. Okay. And I'll tell you some of those things at the end. Okay. Other questions? Okay. So what's going to happen? Let's imagine you travel to Centerline. This is probably the most famous thing that people watch for when they are on the center line of a total solar eclipse. The photographers go wild. You will see a billion of these pictures when the total solar eclipse happens. It's called the diamond ring. And this is the moment that the moon finally eclipses almost the entire sun. And there's some little bit that's left, some little portion of the sun that's shining between the topography of the moon and still looks bright. And if this is the point, you'll hear people scream diamond ring, All the photographers are click, 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 trying to get a picture, and we all can take off our eclipse glasses at this point. Because when the moon completely blocks the sun, it's not bright. And it's safe for you to look at what's going on. Okay, so when you hear, especially if you're with other people, I was in Casper with 5,000 amateur astronomers, and you just hear everyone screaming, "Diamond ring!" Right? And then all the glasses come off, and this is what you see. You're standing in the shadow of the moon. It is dark, like it's dark at night, and there's a big black spot up where the sun is supposed to be. It is stunning if you've never seen one before. Literally nothing can prepare you. I mean, I'm an astronomer. I know what this is all about. Nothing can prepare you for freaking A, man. The sun's gone. Okay, and just black where it's supposed to be. It's amazing. Okay, but this is the photographer's dream, the diamond ring. Okay, there will be one on the other side when the moon moves off of the sun. Okay, the diamond ring appears, and that they'll scream "diamond ring," and that's the time to put your glasses back on again. Okay. Now there are other things similar to this. So this is another famous one. This is called Bailey's beads, and it happens right near the beginning and end again. And what this is that the moon is just like the Earth. It's not flat like a pool ball, right? It's got topography. It's got mountains and canyons and plains, just like the Earth. And so as the moon finally blocks the sun, the tall mountains are blocking the sun, and then the valleys between them are still letting light through. And so Bailey's beads are these little bright points of light coming through the topography of the moon at that last moment before the sun is completely blocked out. Okay, so this you will also hear the photographers yelling about. Okay, but as you can see it if you're paying attention. It's just a fraction of a moment. If you blink at that moment, you won't see them. But if you're watching, you can. Okay, now you'll notice this is photography. You'll see these red spots around the edges. Okay, those are the solar prominences, the kinds of solar flares that you often see pictures of. When the sun's blocked out, all the brightness of the sun is hidden, and you can see those kind of fine details, which is kind of cool. Okay, but during totality, if you're on the center line, the sun is completely blocked, and all that's left, as I drew in that cartoon near the beginning, is the atmosphere of the sun. The stuff out here that's not very bright at all, that we call the corona, the crown of the sun. It's just like the Earth has an atmosphere, the sun has an atmosphere, and all that stuff that's bubbling up all the time goes into the corona. And there are lots of pictures of it, but there are very few that I've ever seen that were close to what I remember seeing the moment I was standing there outside, staring at the corona of the sun, except this one. This is what it looks like. This is the color. It was this kind of grayish blue color, and you can see the streamers streaming away from the sun. Okay, so this is an actual picture from the 2017 one. This is the one I saw, and I'm like, yeah, that's it. I saw this picture. I was like, that's what I saw, right? And so you can see these just diaphanous, ephemeral little trailers of gas and dust streaming off of the sun. And for the entire time the sun's eclipsed, okay, so for most of the eclipse track across the United States, it will be between 4 and 3 minutes in April. This is what it's going to look like. And you can stand there, and it will go so fast you can't believe it. It's like the shortest 3 minutes of your life, okay? But you can stare and see the sun and stare at its corona. Now, I chose not to photograph it. But the thing I did do is I just hit the record on the voice memo of my phone, and it's awesome to go back. I should put it in the talk. It's awesome to go back and just listen to everyone just stupefied by what they're seeing, right? It's just totally cool, okay? Now, if you read about eclipses, there are other things. You absolutely will notice it gets cold because there's like no heat, right? The sun's blocked. It's gone. It's just like nighttime. The animals change. You will hear the crickets start chirping, right? The frogs will start going nuts. The birds will stop, right? They think it's night. Okay. So the world literally does respond.
And people, honestly, gosh, people start streaming.
Oh yeah, absolutely.
Yeah.
Yeah. that just it's not like anything you've ever experienced. And like I said, I'm an astronomer. I've known about this. I've read about this. I've taught about this for decades. And in 2017 is the very first one I'd ever seen. Right. And I'm just like, oh my God, what is this all about? Right. And so, it transforms people, right? There are people who, right, literally, if you just listen to people around you, the very first thing that's over is when's the next one, right? And people, I have a friend, he's been to 27 of them because he's just like, when's the next one? And he goes, right? So this is a deeply cool thing. And it's one of the few things in the astronomy world where you can experience happening in real time. If you and I go out and we look at Jupiter through the telescope, and then we go look through Jupiter at the telescope next year, it's going to kind of look like Jupiter. It doesn't change, right? If I show you the Andromeda Galaxy, it looks like the Andromeda Galaxy. The eclipse happens in real time, right? It's 3 minutes of your life that are never going to be that way ever again because the eclipse isn't going to happen again. So if you want to live up close and personal to the cosmos, this is the way to do it. Okay? Okay. Other questions? Okay. So this is for the whole kind of 3-4 hours that it takes. If you just kind of keep looking at the sun through your eclipse glasses, it will slowly, and then this is kind of what it'll look like in Chicago. You'll just see a little crescent left. There's the diamond ring. Diamond ring will come back on the other side, and then it'll just move across. So that's faster than it will happen. This will take 3.5 minutes if you're on center line for the upcoming eclipse. Okay? It's cool. I'm telling you. Okay. If you're in Chicago, this is what it'll look like. Okay. It's going to be too bright to look at. If you want to look at it, what do? Put on your eclipse glasses. Okay. And at totality, this is what you'll see. All of this is going to be black because the eclipse glasses don't let through that much light, but you'll see this very, very thin crescent. All 96% of the sun will be covered from Chicago in April. Okay, and that's about the same as what it was the last eclipse in 2017. Okay.
And what's the closest, like Carbondale is the closest place for totality?
Carbondale is where in Illinois it's closest. So if we go back to this map, I think Indianapolis is on the center line, very close. Okay, so anywhere in the center of Indiana and Northwest Ohio is the closest you can get. Okay, now if you want to couple that with weather discussions, the farther you go towards the southwest, the luckier you'll be. Right. But anywhere up in this, it's still stick season in Vermont. So, don't go to Vermont. Well, maybe go to Vermont. I don't know. But right. So I have friends who are like, my folks have a cabin in the Adirondacks. I'm like, what's the weather like in the Adirondacks in April? Right. So anyways, yeah, but this is the closest you can get and definitely be on the center line. But just be cognizant of the weather. Okay. There are weather sites. They'll tell you historically what's the weather like on April 8th in Indianapolis. You can look it up. Take your chances. Right. Okay. That's a good question. Other questions? Natalie.
One from when was the first eclipse predicted?
That's a good question. So
Can you repeat the question?
when was the first eclipse predicted? So I don't know about prediction. The first historical eclipse that's in the written human historical record is in 1223 BCE. So 3,000 years ago is the first written record of a human record of an eclipse. But I don't know when the first prediction was done. That's a good question. I don't know the answer to that. Okay. Other questions? Okay. Okay. So let's give you the times for Chicago. We'll go through all the cool pictures. This is what it looked like. It was amazing. Okay. I searched the web high and low. I was like, someone must have taken a picture that looks like that's the one. It was beautiful. So, okay. So, what you see here, so this is a close-up of that track. You were just asking what's the closest we can get to. You can see Indiana, but see these contours, right? So these contours are the length of totality. So basically, if you're there, how long will the sun be blotted out? And so out here in the outer band, this is like 30 seconds. This is like a minute and a half. So about 2 minutes if you go to Indianapolis. But if you go south of Indiana, down here, it's going to be like 3 minutes, 3.5 minutes. So there's a little bit of consideration there too if you want to just bask in the shadow, right? Okay. Okay. So just be cognizant. So here's the Chicago times. If you're going to stay in Chicago And we're going to have awesome weather on April 8th next year, I'm sure of it. Okay, the partial eclipse, that first moment a nibble of the sun's taken out, will start at 12:51. Okay, so you'll have a nice lunch, you'll go sit out for a spring picnic and watch the eclipse. Okay, sun is basically full sun, just a little nibble, use your eclipse glasses. The maximum, that little crescent I showed you, will happen at 2:07. So it'll take about an hour and 15 minutes or so, hour and 20 minutes. And then the sun's going to be maximally blotted out. Still too bright to look at with your naked eye, so use your eclipse glasses. Okay, if you're hanging out with us at Sierra, at Dearborn, or you're hanging out with Adler, they'll have telescopes there, special telescopes that you can look through. But if you're on your own, use your eclipse glasses. Okay. Moon will begin to move off the sun, and by 3:22 in the afternoon, that'll be the end. Okay? Every moment in Chicago, you have to use your eclipse glasses. Okay. I gave you eclipse glasses. Just wear them around. You'll look cool. Okay? Okay. Questions? Okay. Wear your eclipse glasses. This is the only thing you have to remember. Okay? Wear your eclipse glasses. Okay. If you go to center line and you are in totality, that's the only time right after the diamond ring that you can take your eclipse glasses off. And then right when the moon moves off, you'll see it. The sun's going to get bright. Your shadow will reappear. Put your eclipse glasses back on. You don't have to be right on the moment. It's just like accidentally turning and facing the sun, right? But don't just stare at the sun. Okay? Wear your eclipse glasses. But, right? You were responsible for taking care of the eclipse glasses. You put them in an envelope. You put them someplace where you wouldn't lose them. And you're going to lose them. So then what do you do? Well, you can still observe the eclipse. If you happen to be walking down the street and in the middle of the eclipse, the sun is shining through a tree, the dappled light of the leaves will cast little mini projections of the eclipse on the ground. Which is, if you know that and you're walking around, you're like, whoa, there's an eclipse today. Because normally it just projects normal little shadows. But during an eclipse, it will project little crescent moons. Now it's April in Chicago. Sometimes it's still stick season here in Chicago too, just like it is in Vermont. So, make your own little waffles with your fingers. And if you project them through the little waffle holes between your fingers, it will project little eclipses. But if you want to really be cool, run inside and be like, Mom, did you wash the spaghetti colander? You can take your colander outside and look at its shadow. Every little hole in your spaghetti colander or in your salad spoon, right? Oh, I guess that's the spoon and this is spaghetti colander, will cast little tiny projections of the eclipse. And that will work during the entire eclipse, from the moment the little thing gets spitting out to the moment of maximum. We did this while we were waiting on the center line to watch the sun. Okay. So for those of you who are nerds, this is called pinhole projection. All the photography nerds out there. Okay. I'm sure Grace has a billion books in the library about it. Okay. Now, you probably can't see it on the projection, but there are little crescent moons here. Does anyone want to guess what I'm projecting right here with? That? What?
It almost looks like a keyhole.
No, it's not a keyhole. That is a Ritz cracker. The holes on a Ritz cracker are perfect eclipse observation devices. I should totally get a sponsorship from Ritz. Okay, right? We're hanging out, we're eating our snacks, and we're like, these have holes in it. And sure enough, if you look, it's little mini eclipses. Okay, which brings up an interesting point, right? You're spending this kind of momentous few hours of your life watching this, and if you go read my blog post, I have pictures from my journal of just things I wrote down while we were watching. I got all my friends who were there with me to sign my journal page and everything. But you're going to want to have something to remember what it was like and what you were doing. That's why I recorded, right? I just recorded the sound. I go back and listen to it sometimes. It's really awesome. But I didn't want to have the camera between me and the eclipse because I'd never seen one before. And as a result, I don't have a picture of the eclipse that I took, but I got to stare at it for a long, long time, which I really enjoyed. And plus, I know there are way better eclipse photographers out there than I am, right? So my wife went and saw the last launch of the space shuttle, and NASA's like, listen, everybody, we got way better cameras than you. Do not take a picture of the space shuttle launch, right? And she's like, okay, I won't. And we just living in the moment of these kind of singular events in your life is probably worth it. Okay, but you do want to remember what was it like and what was it doing. And so we were hanging out eating Ritz crackers, and my friend Stacy I was with, she's like, look what I can do with Oreos, right? So she'd look through her eclipse glasses and she'd bite her Oreo off to show you exactly what the moon looked like at that moment. Okay, so do something cool. Okay, and this is the moment of totality, as you might. Okay. So do something so you can remember, right? Don't worry about, that you're not going to have some record. Just kind of be cognizant and aware of this moment you're spending with this kind of unique thing that happens. And it really is a unique thing. We live here on Earth at a moment in time when this can happen. But there's no place else in the solar system where we have eclipses like we do on Earth, because we just happen to be at a special moment in the Earth's history where the moon's the right distance away from Earth to block the sun. The moon is slowly spiraling away from the Earth. And in 730 million years, there will be no more total solar eclipses. You and I live at a unique moment in time. And so it's worth thinking about that when you're standing out there waiting for it to happen. Okay? Okay. So that's all I'm going to tell you. Your lesson you were supposed to learn during this talk is?
Wear your glasses.
Wear your eclipse glasses. Okay, this is my daughter Kate at the annular solar eclipse in 2012. She just wore her glasses the whole time and it was great fun. Okay, so just wear them. I like to leave you with stuff to read and learn on your own. You certainly can contact me, and there will be plenty of resources. So NASA has its own eclipse website. Here's the great American eclipse site that you can go to and get the kind of maps and stuff that I showed you. And then this is NASA's visualization site. So like all the movies I showed you came from NASA's visualization site. So that's a great site to go to if you just want cool things to show your neighbors. There's lots of books that get written. This is from the folks at Astronomy Magazine. This is a guide to the solar eclipse. They'll tell you all the things I just told you. They'll tell you about being safe when you observe. They'll give you maps, tell you how to find amateur astronomers to help you out, the whole 9 yards. Okay.
I do have a question. Like you mentioned the Jupiter, and Jupiter has like 95 moons.
Jupiter has a lot of moons.
Yeah.
Yes.
Do they have like a lot more lunar eclipse then? Or?
Yeah, so Jupiter doesn't, so first, Jupiter doesn't have a solid surface, so you can't stand on Jupiter.
Yeah.
Okay, but if you could, right, the problem with Jupiter's moons is that Jupiter's moons are much, much tinier than ours. Not all of them, but the vast majority of those 95. And so when they pass in front of the sun, they hardly block any of it at all. Okay. Now, the 4 big moons of Jupiter, they're called the Galilean satellites. They absolutely pass between Jupiter and the sun. And we can, from Earth, see their shadows travel across the surface of Jupiter. Okay. You can see it through a telescope in your backyard. Okay. But you can't stand on the surface of Jupiter, so you can't see the eclipses, right? Yeah. That's a good question.
All right, you've now scared the dickens out of me.
Good. Okay.
The moon is pulling away from the Earth?
Yes. So the moon is exerting its influence on the Earth all the time. What's it doing? What does the Earth do to the
Gravitational
Tides
pull.
and
it makes the tides.
Yeah.
Okay. So the moon's gravity is not strong enough to make me and you be floaty. Okay, but it's strong enough that it can kind of make the oceans bulge. And as we rotate, we get high tides and low tides. Okay. The energy to make the oceans bulge has to come from somewhere. And the place it comes from is the moon's orbit. And so the consequence of the moon using its energy to raise the tides on Earth is that every year the moon gets about 22 millimeters farther from Earth than it was last year. Yeah, we can measure that. We shoot lasers at the moon. We can measure the distance.
When you say the consequence of it, like it's losing energy gradually.
It's taking energy that was in its orbit and it's dumping it into the Earth's oceans, into the tides. Right? It's like you, right? If you move, you better eat your Snickers bar before you carry all those boxes up the stairs at your new house because it requires energy.
Right.
the moon's lifting the oceans into the bulge that you and I call the high tide. It takes energy.
All right, so let's go back. So in 700 years.
In 700 million years.
700 million years.
Yeah. So you and I will be very old by then.
Very old.
Yeah.
Then in theory, there won't be any more tides. Assuming there's still oceans on the.
Yeah, right.
In the Earth's oceans.
Yeah, so there will still be tides. It's just the tides will be weaker as the moon gets farther away. And the point is that the moon will be far enough away that it can't completely block the sun, but it will still be close enough to have influence on the tides of the Earth.
Okay.
Because it doesn't have to get that much farther away. That's why I mean, we live at this special moment where it's
Right.
exactly the size of the sun in the sky.
And then my last question is. When you talk about the cameras, so if,
Sorry, for taking
Taking
pictures?
pictures of the
Yeah,
eclipse.
okay, yep.
so I have a digital.
Mhm.
Digital reflex camera.
Yep.
whatever the hell they call these things. If I just look through my viewfinder.
Don't
Would
do
the
that.
brightness of the sun still potentially cause blindness?
Yeah, it will burn the
It'll burn the
sensor of your
retina.
camera. It'll burn the sensor of your camera.
Okay,
Yeah, so don't do that.
but my
You-
retina will stay.
Yeah, if you're watching the screen, right? If it's a pass-through reflex camera, like the old-fashioned one, it will, I mean, it's like looking at the sun. If you just do it momentarily, it's not gonna hurt you, but the lens is bigger than your eye. So it's focusing all the light on that lens down to something that'll get
It's
your
gonna
eye.
blow the
which is why it's
CMS
bad.
or
It's
whatever.
gonna blow the CMOS out, that's right. But you can buy, so you know how you can put polarizing filters on the front of your camera? You can buy solar filters that will snap on the front, and then you can take pictures like, not unlike that red one. I showed.
Okay, so that's what they were doing.
That's what they're doing.
had
They
an
have solar
additional
filters.
filter on the front of
They
the
have
camera.
solar filters, yeah. Okay? It's kind of the equivalent of the eclipse glasses for your camera. They're typically glass, they're optical quality, so you can take pictures, blah, 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 blah. Okay? Okay. This is a great book by Tyler Nordgren. Some of you may know Tyler. He's a big proponent of dark skies in the national parks. So he's written some very cool books about this. This is his book about eclipses. It's a very nice book. Okay. And for those of you who read young adult fiction, which, you know, all of us who have kids typically have, this is a great novel by Wendy Mass called Every Solar Star, where it features a whole thing about the eclipse. And so that's a great novel to read. So, okay. So that's all I'm going to say. I will say thank you for your attention. I'm happy to answer questions from Zoom or all of you. And otherwise we'll call it a night. Yeah. You good? Okay. Any questions on Zoom, Natalie? Okay, well, thank you, everyone. I will leave extra glasses with Grace, and you know, come see us, enjoy the eclipse, tell your neighbors, tell your family,
Thank you.
and
so
wear
much
your
for
eclipse
your time.
glasses.
Yeah.
Thank you very much.
Okay.